guys, so we are back again after the Zoom interruption. Now, you can continue working on question 2 and question 3. Raise your hand when you finish question 2. And so we can check that and then we can move on. All right, guys? Ms. Waysam, you are finished with question 2?
Yes, sir.
All right. All right. Just give the others time to see if they will get through with it. All right. All right, so let me, in the meantime, start the steps in question 2. So first, we want to write our equations in matrix form. So we will have 4, 1, minus 3, 3, and that would be our A. Then we have X and Y. That would be the matrix X equal to, we have 7, no, not 7. So we have 1 and 19. And so that would be our matrix K. All right, so our adjoint of A would be 3, 4, 3, minus 1. So that's adj A. And so we have A, 4, minus 3, 1, 3. Then we have X, Y. So this would be A, this would be K. And then now we have add A again, 3, negative 1, 3, 4, times K, which is 1 and 19. So this is add A. And this would be K. All right, so over here we have 3 4s, 12, plus 3 1s, 3. 12 plus 3 will give you 15. So here we should have 15, 15, 0, 0, XY so we would have that equal to 313 plus 3 times 19 will give you what?
57, sir.
57. And then now we have -1 times 1, -1, 4 times 19, give you how much?
76.
So 4 19s minus 1 give you 76, that's what you get?
Yes, sir. 4 times 19, 76.
4 times 19 equal to 76.
Yes, sir.
You subtract 1.
Give us 75.
Okay.
Is it
All right, so here now we would have
so it should be 60 at the top. Positive 3 plus 57 will be 60.
Yeah, I was just going with your calculation. Let's wait some.
Okay, so plus the 3 would give us 60 and then the 75.
60 up here then.
Yes, sir.
And so here we would have 15x and 15y equal to 60, 75. So we equate 15x to 60, we get x equal to 4. So therefore, x is equal to 4. And y would be equal to what? 5. So we have 15y equal to 75. So therefore, y is equal to 5. Everybody got that? Raise your hand if you got that correctly for me, guys. All right. All right, now if you are not yet finished with question 3, just take a snapshot of the screen. What I want to do is go to the inverse matrix method now before we actually run out of time. And then now, the same 3 questions that we did with the adjoint matrix method, you're going to also do them with the inverse matrix method. Maybe we may not have enough time to complete all 3 of them with the inverse matrix method. So whatever time we finish, you're going to finish up these questions for homework. All right, guys? All right, so let me clear what we have here. Let me stop sharing this. So I'm going to go back to all right, so now we're going to be looking at the inverse matrix method. Now, from a definition, we say if 2 matrices A and B such that their product AB is equal to I, and remember I here has to do with the inverse matrix. Sorry, not, yeah. I here would have to do with the identity matrix. All right, so I would be the identity or the unit matrix. Then B is said to be the inverse of A. So what that really means, when you multiply the matrix A times its inverse, you will get the identity matrix. That's what they're saying. So the inverse of A is denoted by the symbol A to the -1. So this is the symbol that we use for A inverse. All right. Now, in order for us to be able to find the inverse, we will have to find what we call the determinant of the matrix. And as the name suggests, the determinant really determines whether or not your matrix has an inverse. So to find an inverse of a matrix, we need to first find the determinant. If the determinant of a matrix is 0, the matrix has no inverse. And in that case, we say that the matrix is singular. Right? When the matrix has no inverse, we say that the matrix is singular. Now, this is how we go about finding the determinant. To find the determinant of a matrix, you multiply the diagonal elements, AD, minus the other two elements, the product of the other two elements. So it is AD minus BC, right? So that's how we find the determinant. Now, the symbol that we use for determinant, we can use either DEA, DETA means the determinant, or we may use this symbol with a two modular sign, which also mean determinant. So if you see this, it means the determinant, or you can see this, and it also means the determinant. And to calculate the determinant, we simply multiply the diagonal elements AD minus the other diagonal elements BC. So it would be AD minus BC. After that, minus before Christ. All right? Is that clear, guys? Now, remember.
No, sir, not clear to me at all.
You will see an example of how to work it. So it won't be so much of a mystery. So we're saying that these A, B, C, D, these will be numbers, right? In matrices where you have actual numbers for A, B, and C, and D, you will calculate the determinant by multiplying the diagonal, the number of A, whatever number is here, and here you multiply these two to get AD. Then you multiply these two to get BC. Then you subtract what you get from the product of BC from the product of AD. That's all we're saying. Is that clear to you now, Ms. Wesa?
Yes, sir, I'm getting it now.
All right, so here we go. Now, we recall that A times its inverse must give you the identity matrix. So we say since their product is equal to the multiplicative identity, then they are reciprocal of each other. All right. So this is what we use to denote our inverse matrix. So if you have the matrix A in this general form, then the inverse of A, denoted by A minus 1, can be found by putting 1 over the determinant, and then you multiply it by the adjoint matrix, right? That's what we get for the inverse. All right. Now this is just a little general in terms of the formula, but let us see how it would look if we do an actual example. All right. Note that if your determinant is 0, because you have this 1 over the determinant, that means this would become 1 over 0. And you know, for mathematics, you cannot divide by 0. So if the determinant is 0, your matrix, the inverse of the matrix, you wouldn't be able to find. So we say the matrix has no inverse if the determinant is 0. And as I mentioned before, when this happens, we say that the matrix is singular. All right. So this is more general what the formula looks like. So it's 1 over AD minus BC times the adjoint matrix. All right, moving to what we mean by singular and non-singular. So a matrix is singular if the determinant is 0. If the determinant is not 0, which means a non-zero number, then we say that the matrix is non-singular. And non-singular means that the matrix has an inverse because the determinant is a number other than 0. And once the matrix has a determinant other than 0, it means you can find the inverse. But if the determinant is 0, then there is no inverse for that matrix. All right, now example 1. If A is a matrix 4, 4, 1, 2, 3, and you have to find the inverse of A, can somebody tell me what to do in order to find the inverse of A based on the formula? First thing, what you would have to do?
Cross multiply, sir.
First, you have to work out the determinant. And remember now, the determinant, anybody remember what the determinant means? So the determinant of A, which sometimes is written DETA, or it can be written DETA to mean the determinant of A. And to work that out, you would multiply AD minus, AD minus BC. All right, now what it means then, these two diagonal would give you AD. So you'd multiply 4 times 3. And then now BC would be based on these two, minus 1 times 2. And here, when we do the calculation, do your multiplication first before you do the subtraction. So 4 3 is 12, minus 1 times 2, 2. So now you would subtract 2 from 12. Then your determinant would be equal to 10. Now the determinant here is a non-zero number, meaning that your matrix would be non-singular. If your determinant was 0, then the matrix would be singular. Is that clear, guys?
Yes, sir.
Singular matrix has no inverse. Non-singular matrix has an inverse. Sometimes CSEC can state that the matrix is singular. You have to know what that means. When the matrix is singular, it means that the determinant is 0, and it means that the matrix has no inverse. Make sure you repeat that in your head, guys. All right, so here the determinant is 10. So clearly this matrix has an inverse. How do we find the inverse? So we write A inverse. If you remember what the formula for A inverse is, it will be 1 over the determinant You put 1 over the determinant, and then you times it, so determinant of A, then you times it by the adjoint of A. All right, so A inverse then would look something like this. 1 over 10, that's what we work out the determinant to be. And the adjoint of A, remember now, you learn how to find the adjoint of A. So you interchange the diagonal elements, so you put 3 and then 4 along the diagonal. Then I change the sign of the other two. So you have -2 and -1. All right, now you're multiplying this matrix by 110. Now if you're multiplying by a fraction, 1 over a number, it's the same as dividing by the denominator. So the inverse of A will be 3 over 10 minus 2 over 10 minus 1 over 10 and then you will have 4 over 10. All right, when you work that out in the decimal form, then your matrix would be 0.3 for the first element. So 0.3. And then for this one over here, it will be negative 0.1. Down here, you would have negative 0.2. Over here, you would have 0.4. And that would give you your A inverse. Now, one of the things that we know about, if you multiply A by the inverse of A, you should get the identity matrix. So if you multiply A times A inverse, so if you want, you could multiply A times A inverse would be equal to 4, 2, 1, 3 times 0, negative 0. So this would be negative 0.3, or just, no, not negative 0.3. That would be just 0.3. Over here we have negative 0.1. Down here we have negative 0.2. Down over here we have 0.4. Now, when you multiply these two matrices together, you should get the identity matrix 1, 0, 0, 1, 0, 0, 1. If you do your multiplication and you don't get that, then the matrix, something is wrong. All right? All right, so with
Sir, question. Sir, how you get the 1 and the 0 and the 0 and the 1 again?
No, that is a given. That is the identity matrix.
Okay, sir. I think I work something out and get it.
No, man, the identity matrix is like when you have the identity number, multiplicative identity or additive identity. So you know that if you multiply the matrix by this matrix, 1, 0, 0, 1, you'll get back the same matrix that you multiply by, because this is the inverse matrix, or the we call it the unit matrix or the identity matrix. It's the same one. All right. Any question about what we just did just now? Guys? All right. Considering that we are close to the ending of the class session, I may have to just recap this in tomorrow's class just for reinforcement. All right, guys? So let us continue. So just to remember that your inverse, to find your inverse, you find the determinant AD minus BC, you put 1 over that, then you find the adjoint, you multiply by the adjoint. That's how you get your inverse matrix. You multiply A times A inverse, you will get your identity matrix. All right, moving along. So here we have our inverse, and when you multiply A times A inverse, you get that. All right, guys? Now, looking now how we can use the A inverse method to solve simultaneous equation. Now, of course, you're going to do the same thing in the first step as you did in the adjoint method. First, you write your simultaneous equation in matrix form. So that's the first step. So therefore, you would write in matrix form like that. Everybody seeing that so far? The next step, you're going to know, if you look at what we have down here, if you multiply A times X, you get K. But if you're solving for X, you would have to divide K. Remember, if you're solving this as an equation, and you're solving for X, you would divide both sides by A. But when you divide this side by A, you get X. All right, so here we would have X equal to K over A, but you know that K over A is the same as K times 1 over A. Now remember, when we talk about inverse and the reciprocal is the same. So 1 over A is the same as A inverse. So it's K times A inverse. So all this is saying, in order for you to solve this equation, you're going to equate, you're going to have X, the matrix X will be equal to K times A inverse. That's all it is saying. So if we follow that, it means that this is what we will get. So here we have X will be equal to A inverse times K. Now, what we have to do, we have to use what we know about A here to find A inverse. So can somebody help me now to find what A inverse is? So A inverse would be equal to what? 1 over the determinant. What is the determinant? 5 3's. So the determinant would be 5 times 3. Five times 3 minus 2 times 4. And then now you times it by the adjoint of A. A adjoint would be 5 And then you have 3. Then you have minus 2, minus 4. All right, so if we simplify that, A inverse then would be equal to 5 3 is 50 minus 8 will give you 7. So you will have 1 over 7. Is that correct, guys? That calculation?
Yes, sir.
All right. So this is our inverse. Now, something to note. It is best when you're working with the inverse, you keep the fraction outside the bracket. Don't multiply it out to the fraction as I did before. Because when you do that, you may have decimals to work with. And it is harder to do your calculation in matrices with decimals, right? So this here going to be A inverse. Just keep it as it is, 1 over 7 times the adjoint matrix, all right? All right, so with that said, now we move to the next stage, which is over here. We are going to take the inverse of A and multiply it by K. So remember now, A inverse is 1 over 7, bracket 5, negative 2, negative 4, 3. So wherever we have A inverse here, we're going to replace it with all of this. All right. So that will give us, so that's what you will get. You'll get it looking like this. So this will be A inverse times K. And what you do, you multiply out the matrix section first. Multiply the 2 matrices first and leaving the fraction for last. So you multiply 5, 12, 60, minus 2 times 23. That would be negative 46. 60 minus 46 will give you what? That's 14.
Yes, sir.
14. And then now you multiply again. 4 times 12, 4 12s, 48. That's negative 48. 3 times 23 will give you 69. 69 minus 48 will give you what? 21?
Yes, sir.
All right. So it means then you will get this afterwards. And then now you can multiply out what is in the bracket now by the 1 over 7, which is simply going to divide each of those by 7. So 14 divided by 7, give it 2, and 21 divided by 7, give it 3. So X would be equal to what? 2, and Y would be equal to 3. All right, so that's what you would get. All right, guys. All right, now what I'm going to ask you to do, guys, because we really don't have enough time to go through any of these questions now. But the same 3 questions that you did with the adjoint method, you're going to try them and come to class tomorrow with your solutions. And then I'll recap the adjoint, the inverse method of solving simultaneous equation. And then we'll go through the same 3 questions tomorrow. And then after that, we'll move on to another topic. All right, guys? So I'm going to stop sharing now.